I request you to please like, share my videos and subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem from the section Differential Equations. This question has appeared in the CSIR National Eligibility Test held in the month of July 2024. The question is related to Cauchy-Euler Equation and its solution. This question is from the part B, is a multiple choice question which carries 3 marks and its question ID is 704042. This question is also suitable for the aspirants of JL, DL, TS set, AP set, IIT JAM and GATE. The given question is, let phi denote the solution to the boundary value problem. In short, call it as BVP. And the equation is xy prime whole prime minus 2y prime plus y by x is equal to 1, where x lies between 1 and e to the power of 4. The boundary conditions given as the value of y at 1 is 0, the value of y at e power 4 is 4 e power 4, then the value of phi of e is, we are given 4 options. Right. Let's now discuss the solution of the problem in detail. We have the given differential equation x y prime whole prime, prime denotes differentiation with respect to x, minus 2y prime plus y by x is equal to 1, where 1 less than x less than e power 4. Right. X y prime now differentiate with respect to x. So it will be x y double prime plus derivative of x is 1 into y prime minus 2y prime plus y by x is equal to 1. Simplifying, we will get x y double prime minus y prime plus y by x is equal to 1. Multiplying throughout by x, we get x square multiplied by y double prime minus x y prime plus y is equal to x. Let's call this as the equation 1. We continue the discussion in the next slide. Right, we have this differential equation, and look at this differential equation carefully. You will come to know that it is a Cauchy-Euler differential equation. Some people call it as homogeneous linear differential equation also. Right. Now, to solve such a kind of a differential equation, we transform, we change the independent variable x to a new independent variable z by means of the substitution x is equal to e power z, or in other words, z is equal to ln x. Obviously, with this substitution, this differential equation will get transformed. So now what we see is x dy by dx is capital dy, where capital D is the derivative with respect to z, that is the differential operator with respect to z, and x square d square y by dx square is d into d minus 1 into y. Now the differential equation 1 now get transformed into d into d minus 1 minus d plus 1 into whole into y is equal to, operating on y, is equal to e power z. Right. Now simplifying, we'll get a d square minus 2d plus 1 operating on y is equal to e power z. Let's call this as the differential equation 2. What is this differential equation? It is a second order non-homogeneous linear differential equation with constant coefficients. Mind you, capital D is d by dz, the operator, differential operator with respect to z. So keep that in mind, and we know the methods of solving this one. To solve this one, first we write down its auxiliary equation. The auxiliary equation is m square minus 2m plus 1, which is m minus 1 whole square is equal to 0, m is equal to 1 twice. So when m is equal to 1 twice, we write down its complementary function as c1 plus c2z whole into e power z. Right. Now we find out its particular integral. This particular integral is 1 by d minus 1 whole square into e power z. Now if you substitute d is equal to 1, the denominator is becoming 0 and d minus 1, it is appearing in the square, and its particular integral will be z square by 2 factorial into e power z. So if it is a d minus 1 to the power of n, it will be z to the power of n by n factorial into e power z. So that's the formula for the particular integral we have written down. So now for the solution is y is equal to complementary function plus particular integral, that is c1 plus c2z into e power z plus z square by factorial 2 is 2 into e power z. Now what is e power z? X. What is z? ln x. Substitute. So y, which is a function of x, is equal to c1 plus c2 into z ln x whole into e power z is x plus z square, that is ln x whole square into e power z is x by 2. So that is your general solution of the given differential equation 1. The above one is general solution for 2, but this is the general solution of the given differential equation. So now move to the next slide for the further discussion, and we have the GS of the given differential equation, that is y of x is equal to c1 plus c2 into ln x whole multiplied by x plus x into ln x whole square by 2. Now to evaluate this arbitrary constant c1 and c2, we are given the boundary conditions. So y of 1 is equal to 0. So in the above general solution, put x is equal to 0 and y, x is equal to 1, y is equal to 0. So put y is equal to 0 when x is 1. So then this will be y, that is 0 is equal to c1 into x. X is 1. c1 plus c2 into ln of 1, 0. And here also ln of 1 whole square, that's 0. So you will get 0 is equal to c1. Therefore the above general solution will become y of x is equal to c2x ln x plus x times ln x whole square by 2. To evaluate c2, we are given the second boundary condition, that y at e power 4 is 4e to the power of 4. So substitute in this equation, x is equal to e power 4 and y is 4e to the power of 4. So the y, 4e to the power of 4, is equal to c2 into x e power 4 into ln x ln e to the power of 4 plus x e to the power of 4 ln of e power 4 whole square by 2. Ln of e power 4 is 4. So it will be 4 c2 e power 4 plus e power 4 into 4 square, 16 by 2, 8 e power 4. So simplifying, 4c2 e power 4 is equal to minus 4 e power 4. 4 e power 4, 4 e power 4 cancels, c2 is equal to minus 1. This is the solution of the given differential equation with these boundary conditions. It's in fact a particular solution. And it is given that this solution to be phi. Here, look at it. Look at in the exam. In the example, look at in the example. So phi. So this is phi of x. Now required to find phi of e. So phi of e means wherever there is x, substitute e. So this will imply phi of e is equal to minus e ln e plus e into ln e whole square by 2. Ln e is 1. So it will be minus e plus e by 2. That is minus e by 2. Therefore, the answer that is required, that is phi of e. The answer for phi of e. So phi of e is minus e by 2. This appears against option 1. Therefore, the answer to this question is option 1. That is the detailed discussion of the solution of the given problem. It will take a little bit of time, but otherwise it is a straightforward question. I am sure that you have understood the solution of this problem. You have been watching my videos. Please like and share the videos and subscribe my channel if you have not already subscribed. I wish you all the best. Thank you.